I've been mildly obsessed with 3D printing for over a decade now. And for nearly just as long, I've been fascinated with the idea of 3D scanning. The idea of scanning a real-world object, modifying it, and then printing it back out just opens up so many possibilities. The problem is that every time I've tried out 3D scanning in the past, it's been pretty underwhelming. Between inconsistent results and clunky software, I never felt like it was ready for everyday use, and for the most part, I've avoided it for the past 5 years. With how much the printers have evolved in a short time, I've been really curious to see what the current state of 3D scanning technology looks like. When Revopoint reached out and asked if I was interested in testing out their new MetroY scanner, it felt like the perfect opportunity to find out for myself. I've had this scanner for a couple of months now, and I have learned a lot. Not just about the scanner, but about 3D scanning as a whole and sort of what you can expect and what its capabilities are as of today. In this video, we'll dive into the MetroY. We'll go over the setup process, take a look at some real-world scans, and I'll do my best to share everything that I've learned along the way. So with all that being said, and without further ado, let's get right into today's video. Let's start by running through the scanner's specs. And for clarity, there are two versions of this scanner. There is the MetroY, which is the version I have and what I've tested, and there is the MetroY Pro. And there are some key differences between these two versions that we'll cover in just a moment. The MetroY uses blue light structured scanning to capture data and generate a point cloud. This works by projecting a series of lines onto the surface of the object. Blue light's used because it has a shorter wavelength, which means it can capture finer detail, and that leads to higher resolution scans. Those projected lines reflect back into the scanner's depth cameras. And by measuring how those lines deform across the surface, the scanner calculates distance and builds the point cloud, which is then what we use to create our final mesh. There's a lot of different specs on the product page for this scanner, which I'll have on screen, but I'll go through and just point out a few of the key details. This scanner is intended to be used with objects ranging from small to medium, and the scanning distance, or the distance away from the object you need to hold the scanner, is between 200 to 400 millimeters. Based on the minimum and maximum scan volumes, this range is from 10 millimeters all the way up to a full meter in volume. You'll see specs for single frame precision and accuracy, but the one that really matters when scanning larger objects is volumetric accuracy. In this case, it's rated at 0.02 plus 0.04 millimeters per meter of object length, which should allow for some very precise scans once everything is dialed in. One important thing to note is that this scanner is not intended for outdoor use, and because the projected blue light is using a Class 1 laser, this is not something that you want to be scanning faces with. Revopoint states that it can be used for other body parts, but if your primary use case for 3D scanning is to scan people and animals, there are other options out there that don't use blue light. Some of the key differences between the MetroY and Pro come in the form of faster scanning speeds, full field structured light scanning, color scanning in auto turntable mode, additional tracking methods, and support for their dual axis turntable. There are a few other differences as well, so if you're interested in checking that out, I will have the link in the description. Revopoint did offer to send me the Pro model, and looking around at videos that exist, it seems that most people are testing the Pro version. However, my goal with this video wasn't to just test the most expensive version of the scanner that they had available. I wanted to see what kind of results someone could expect while trying to stick as close as possible to that $1,000 price point. One thing I learned very early on is that capturing and computing the data gathered by the 3D scanner is pretty demanding on your computer's hardware. My daily driver is a MacBook with an M2 Pro CPU, and that's actually below the recommended specifications for this scanner. I believe this primarily resulted in slower processing times, which I didn't mind too much, but if you're going to be scanning a lot and scanning larger things, make sure that you meet those system requirements. The MetroY came packaged nicely, and inside of the cardboard box, everything was packed neatly inside of a foam-lined briefcase. Inside the case, you get the scanner, power and data cables, a calibration board, marker sheets, and your usual documentation. I requested the mobile kit for mine, which comes with a handheld power bank for the scanner, as well as a phone attachment and a smaller USB cable to power the scanner directly from this device. If you end up going with the Pro model, it also includes that mobile kit, as well as a small tripod and Revopoint's 2-axis turntable. The scanner itself is primarily made up of a plastic shell and comes in just under 1 pound. There's a grippy texture along the outside of the scanner, and I found it to be pretty comfortable in the hand, which is important because if you're not using something like the mobile kit or some sort of tripod, you will be holding it directly, and depending on what you're scanning, you might be holding it for fairly long periods of time. Towards the top, there's a vent and an internal fan that automatically runs when the scanner is powered on, along with a few buttons for directly interacting with the device. This includes a pause and start button, exposure adjustment, and a menu button. Really, the only one I found myself using during the scanning process was the pause play button, so that way I could set the device down and take a closer look at my scan. On the opposite end of the scanner, we have our single USB-C input that is used for both data and power. Looking at the front, there are quite a few lenses. There are 2 depth cameras that are both surrounded by 6 blue fill lights, a smaller RGB camera, and in the center is our multi-line laser projector. On both of the outer sides, there's sort of these rubber or foam-like standoffs that allow you to place the scanner face down without having to worry about accidentally scratching or damaging any of those lenses. Also, there is a built-in threaded hole on the side, which is what you'll use to attach it to the mobile kit or some other form of tripod. Today's video is brought to you by PCBWay. With over a decade of experience, PCBWay offers high-quality PCB prototyping and fabrication solutions. Along with PCBs, they also provide CNC machining, 3D printing, sheet metal fabrication, and injection molding services. I've used PCBWay for a range of projects over the years, including small batches of PCBs, plus CNC and SLM parts for custom printer builds. I've always been really impressed with their quality and super fast turnaround times. If you're working on your own project but need some help bringing it to life, check out the link in the description below to see everything PCBWay has to offer, and to get $5 off your first order today. As for software, the MetroY uses Revopoint's Revo Metro that can be downloaded directly from the manufacturer's website. This is the program we use to capture all of our point cloud data, as well as modify both the point cloud as well as our mesh. The scanner is calibrated at factory and even comes with a little QC calibration check card, but you need to verify accuracy before you run your first scan. This is a pretty quick process and uses a built-in utility in their software, along with the glass calibration board that ships with the scanner. Holding the scanner horizontally at 30 centimeters from the board, it automatically grabs the needed data and tells you if it passed the check. As long as it passes the check, you are good to move forward, but if for some reason it fails, you'll need to run through the full calibration process, which basically has you holding the scanner at different heights and different angles to get all of the calibration data and dial it in. This is not a process that you'll need to repeat often, and their documentation states that if you start to scan things and get really rough surfaces, or it's unable to recognize or identify the markers, that's a good sign that you might need to rerun that calibration. For connecting to the scanner, there are a few different options, with the first one being wireless. In that mode, the scanner puts out its own Wi-Fi hotspot that you'll then connect to from your computer, and then you'll just use it alongside the software completely untethered. The second option, if you have the Pro version or purchase the mobile kit, is wireless untethered, but using your phone to monitor the scan process. This is really what I was hoping to use and the reason why I asked for the mobile kit, but unfortunately at the time of recording, the Mirror app on the computer side is not compatible with Mac OS Tahoe. When I asked them maybe 45 days ago at this point if they had an ETA, I didn't get any sort of concrete date, so I was not able to use the phone for this scan testing. For my first sort of test scan, I tried out the wireless mode thinking that would probably be my preference, but I quickly discovered that I didn't love having to disconnect my computer from the network to connect to the scanner's hotspot. And also, based off of the location of my computer, I had a really hard time looking over and seeing how the scan was going or what sort of gaps I had using that wireless mode. So outside of that initial test, I decided to stick with the USB. Once you see the scanner connected, click New Project to name the scan and move into the Scanning and Editing workspace. As far as I can recall, this was my first experience ever using a blue light laser, and as mentioned, it had been about 5-ish years, and I was just about instantly overwhelmed. I recently picked up a Game Boy that I thought would be fun to scan just to see how it would do with all of the little details, but after clicking start and having the software yell at me saying it couldn't see enough markers, I decided to call it there and spent the next day or two just reading as much as I could on Revopoint's website and watching videos on 3D scanning and specifically blue light 3D scanning, and boy did I learn a lot. The included sticker markers will quickly become your best friend. These are what allow the scanner to maintain tracking as well as stitch your scans together, and you need a handful of them in view at all time. Also, once you start scanning, they absolutely cannot move. For smaller part scans, I highly recommend creating a reusable platform that you stick these markers directly to. Whatever you decide to use as your reusable object or surface to place things on, it needs to be rigid and it needs to be flat. I cannot remember which video I watched where someone used the MetroY carrying case for their reusable object or the reusable surface, but I love that idea, so I took the case that came with mine, flipped it over, and placed a bunch of those markers kind of all over it. I saw different information regarding how close or far apart the grouping should or needs to be, but the thing I did see consistently was that you don't want to place these markers really in a pattern. You sort of want them to be at random. If you're working with larger parts, like for example the Snapmaker U1, which we'll talk a little bit more on later, you need to place those markers directly on the object you're scanning. Depending on what you're scanning, you might need to get the markers up off of the flat surface. That way, if you're holding it at some sort of an angle or higher up, it still is able to capture and track these markers. And Revopoint does sell an official scan block reusable marker kit, but having access to 3D printers, I did a quick search and found a bunch of different models that I printed out and basically stuck these markers onto. And so these are really nice because depending on what you're scanning, you can just kind of place them with one more time, the key thing being you don't want these things to move at all once you start scanning. These models have little magnets, which is cool. So if you're scanning something that is magnetic, you could just place them on there. Unfortunately, that wasn't the case for any of the things I tested out. With my surface coated in stickers and my Game Boy in place, I was ready to scan. For scan modes, you have cross lines, parallel lines, and single line, which directly controls the projected blue lines during your scanning process. Pretty much everything I scanned using cross lines worked the best. It's the fastest mode, as well as it provides pretty good detail. If you need some higher resolution, the parallel lines are supposed to be able to provide that in certain instances. And from just about everything I read, the single line mode seems to be for situations where you have a deeper hole or cavity or maybe a threaded hole that you're trying to capture some details on. That would be a situation where you might want to experiment with using the single line mode. I stuck with high accuracy for all of my scans and marker tracking for all but one. We will briefly touch on the global marker tracking mode a little bit later in this video. The final adjustment option is selecting whether you're scanning something normal or whether it is a metallic object or a black object. And once you select that, click start and you are ready to go off and scan. The software gives you live feedback during the entire scanning process, which is something I found incredibly helpful. As you are scanning things, it will sort of go from like a nothingness to like a yellowy orange and then finally a blue as it fills in that scanning data. And that lets you know if you see a section that's looking not blue, that you need to go over it a little bit more to make sure you've captured enough of that detail. Aside from making sure I was actually scanning all parts of my model, the other side I reference constantly while scanning is the bar on the right side. This bar tells you whether you're too close, too far, or just right in terms of distance from the surface of what you're scanning. And I imagine with time, you'll get better at just naturally knowing my arm needs to be approximately this far away. But when starting off, especially, having that instant feedback is very useful. I slowly worked my way around the Game Boy until I was happy with all of the results I saw, and then I clicked complete. From here, I flipped over the Game Boy to the other side, clicked new scan, and repeated this exact same process, so that way I had a scan of both halves with some overlap of that Game Boy. Now that I had my two scans, I was ready to process them. And before you're able to merge multiple scans together, or in this case, my two halves of scans, you need to go through and process the point cloud data individually. All this is done using the options found in the point cloud edit section of the top toolbar, along with the menu on the right side. For Fusion, I typically just went with whatever the software recommended as my value. Isolation is used to remove any point cloud data within a tolerance that is away from sort of the main surface or main body of your point cloud. And overlay helps to remove some of the points that overlap on your point cloud surface. You can also smooth or simplify your point cloud in this segment, but for most of my testing, I found that I preferred to do this once I had created my mesh. The tools in the toolbar on the right-hand side are extremely helpful for quickly grabbing and removing things that you picked up in your scan, like scanning blocks or just sort of random objects or artifacts that may have been around the object you are intending to scan. The one I specifically found myself using the most often was Clip, where you drag a line, and depending on whether you drag left, right, up, or down, there's an arrow pointing in a direction, and it selects everything in that direction so you can quickly delete it. Once I had my two models fused and cleaned up, I was ready to merge them together. To do this, click on the merge option and then select the scans from the left side you want to merge together. I use the automatic alignment for all of my testing and found it to work really well. This lets you preview how it's going to overlay your scans, and then you can generate a new scan essentially that just creates an object that has both scans inside of it. While for most of my testing, with the exception of maybe the horse, I only did this with two objects. You can repeat this process as many times as you want. So if you've got, say, 8 scans or something like that, you do need to do 2 at a time, but you can keep basically stacking those scans to create a final scan containing all of these sort of sub-assembly scans that you grabbed. Now that we have our scans aligned, it is time to turn them into a mesh. This process basically takes that point cloud data and converts it into our mesh model. A mesh model is created using a series of polygons, and since just about everyone watching this channel is probably familiar with 3D printing, just picture something like an STL file. Once the mesh is generated, you have similar options to remove any floating objects, fill in holes, smooth surfaces, and simplify the mesh to reduce your file size. With the scan I recorded, I tried using a combination of cross lines, parallel lines, and single line to get some of the ports of the Game Boy, but when I went and meshed all of those things together, I noticed some really weird, rough-looking surface artifacts. When I contacted Revopoint, they let me know that it's not that uncommon when meshing models that something like that may get introduced, and that sometimes it could be due to the environmental circumstances where the different models are grabbed. However, I recorded both of them, or all of them, back to back to back in the studio with the same lighting, so I don't believe that that is the case with this instance. I ended up redoing this process just using the crossed line scans, and I got way better results. The main areas I had some issues with was the screen as well as the sticker on the game cartridge, which was due to them being reflective. Outside of this, I was really pleased with the results that I got. After this, I was feeling like I had a much better understanding of the overall process and workflow, so I moved on to scanning some additional objects. With each scan, I learned more and more about what scanned well, what didn't scan well, and some of the things I can do to improve upon my future scans. Let's run through each of these examples, starting with the horse. When I grabbed this model, I thought this is going to be a piece of cake, especially considering just how simple overall the geometry of it is. And this was largely the case. However, when I grabbed it, I didn't consider that the hooves on this horse are black. And so when I did my first initial scan, all the details of the horse captured well, but he was missing his feet or the hooves. It was just very difficult for me to capture that detail. What I ended up doing was changing my second scan. So I had the primary scan, then I grabbed a second one, and I think I put the horse on his side and set the mode to black object. And so I did one scan of just really focusing on the hooves from one angle, flipped him over and did one other scan of the hooves from the different angle. And once I merged all that together, I was really happy with what the end result looked like. For the Pocket Osmo, this was probably the most impressed I was with any of the scans that I did. It's a fairly small device. There's kind of a lot of little details across the surface like joysticks and buttons, and the object is also black. So for this, I just set it to cross lines with the mode set to black. I believe it was just 2 scans, one at the top and then the second one flipped over on the bottom, and the end results were awesome. I did have to, similar to with the Game Boy, the screen being so reflective, I ended up just using fill holes and I think plane to just sort of fix or fill that rectangle, and then a couple of the little vents that didn't capture perfectly. But outside of that, it just did an awesome job with scanning this. Since there's a metal or metallic mode, I really wanted to see what that looked like. So I stole one of the jaws off of my rotary vise and laid it down and tried my best to scan it. And even after doing a bit of cleanup and trying to isolate some stuff, it just really did not turn out that well. For something like this that is a metallic part, I would highly recommend picking up some scanning spray or something similar to that, where you basically spray this product on it, it coats the surface with a really thin film and makes it so it's not reflective, and the scanner's able to capture that data much easier. Even though they have the metallic mode, if you go on the product page, it does state that they do recommend using scanning spray basically when it's possible. The next object I scanned was this piece of black pipe, which is basically the top portion of a sprinkler valve that I was trying to diagnose last year when I had some issues with my irrigation. We had already scanned a black object, so I knew it was capable of doing that, but this is, if you can see that coming through, a more reflective black object, so I was curious to see how it would handle something like this. Overall, I was really pleased with the result of this. I think that the external geometry did an awesome job. For the internal geometry, this is one of those situations where I think this would be a great model for me to go back in with the single line mode and just see how deep into the cavity I'm able to capture as far as threads and then the sort of main opening here. I played around with a turntable that I have here that I just use sometimes for video work, and I strongly believe that anybody who's going to be scanning smaller objects, having a turntable is a must. Having the object rotate to you and your scanner is just way nicer than trying to go all the way around and walk in circles, especially in my case using the USB. I had to constantly be mindful of the USB and not hit the object or hit any of my markers. So I think a turntable is absolutely an incredible accessory to have for someone doing 3D scanning. During my testing and all the research I did online, I came across a YouTube video from Chris Borg where he designed an absolutely awesome turntable that is intended to be used with 3D scanning. Not only can it do things like adjust speed, and I believe it even had the ability to sort of tick turn, so that way it's not just rapidly moving, but the top surface of it, you can use little 3D printed parts to then position your object to be scanned at any angle, which will be really useful for models that don't have just a flat base to be able to capture all of that detail. His particular design is definitely up there on my list if I can figure out the PCB side of things, and I'm hoping to eventually add it to my 3D scanning toolkit. The final thing I wanted to try scanning was a larger object, and when I was thinking in my head about what is it that I want to scan, I happened to look over and see the Snapmaker U1 and thought it would be neat to try to scan the sort of top portion of it That way I can have a reference if I want to try to design and print out some kind of a top hat enclosure for it. The first part of this process, and arguably one of the most time consuming, if not the most time consuming, was just applying these sticker tracker markers all over the upper area on the side here, because I did want to capture some of this detail, as well as at the very top where the enclosure would be sitting on. For this, I wanted to use the global marker tracking, which I briefly mentioned earlier. This mode has you scan all of the different markers all over whatever it is that you've placed them on. It doesn't actually capture any geometry. It's just generating a map layout. And this is useful for larger objects to help maintain a high level of accuracy. And once you've scanned all the markers and you have your map, then you go and do the regular scanning process, which really isn't any different than any of the other objects that we've scanned. The biggest issue I ran into with scanning this was just not having enough markers in view. It kept yelling at me. And the big part of that issue was especially this top portion, the lip at like the very front and even the back here with these tubes and wires. It's hard to have enough surface area to place stickers. I could have placed more of them close together, I suppose, but I ended up just trying to be mindful of the angle I was pointing the scanner. So that way when I was capturing the top, I was also at least having a couple of these side markers in focus. I did end up losing my tracking once or twice, and so in this case I ended up doing 2 scans. One scan in regular mode where I basically captured all of the side geometry and a little bit of the top, and then a second scan set to black because the top lip is black versus the white side panels, and that's the one that was more detailed that I used to capture all of the top panel geometry. Once I overlaid them, I saw a similar rough texturing to what I saw with the Game Boy scan that I did using a few different scanning modes. But I was able to cut away most of it, leaving me just with the upper lip portion, which is really what I was wanting. Great, we've looked at a few different scans, a few different situations, and what was needed to scan them. But now that we have our mesh model, what can we actually do with it? And that is a completely separate can of worms, and honestly a skill set all in its own. The file produced is a mesh file, which as mentioned earlier is what an STL is or an OBJ is, but how many of you watching this video have tried to do something with an STL file or an OBJ file outside of just 3D printing it? For starters, when you scan an object, as far as I can tell, there really isn't any form of alignment, and your finished object is sort of just floating at some kind of an angle in a plane somewhere. I did a lot of digging into just this specifically and ended up playing around both with trying to align things using Mesh Mixer, which, boy, that's a throwback, as well as Fusion 360. For the horse file, I just wanted to try to print out a copy of the original toy. For this one, I tried using Mesh Mixer by creating a pivot point and rotating it so that the base of the feet was face down. When I imported it into the slicer and went to slice the file, I discovered that the bottom was not perfectly flat, which we're scanning and generating mesh files, which are polygons, so it's never going to be perfectly flat. And instead of having a weird first layer that maybe needed supports or could have come off the bed, I used the slicer's built-in cut utility to cut off a fraction of a millimeter, giving me a flat base that I was then able to print out. I was really pleased with the end result and am debating on, in the slicer, painting a model to try to replicate the colors in a physical version as close as I can to the original one. But the next morning after I scanned it, when I went to my son and pulled out his horse behind my back and then a copy of his horse in yellow, the look on his face is pretty much exactly how I felt when I took this thing off of the printer. It was just really cool to see a copy of the thing I scanned, even if it was a fairly simple model. With the Pocket Osmo, my initial thought for scanning it was that it would be cool to get its geometry so I can use it to create some kind of a case that I could use along with its batteries and maybe my mics for if I'm going to take it somewhere for travel. So in that case, I wasn't interested in replicating the original model, but instead grabbing some information from it. So for this, I imported it into Fusion 360. Cloud42 has an excellent video where he takes a scan of his mill, imports it into Fusion 360, and then uses that to create some reference geometry that he can build add-ons for his mill from. Using that video and one or two others, I was able to create a sketch from a slice of my 3D scan. From here, I created an offset of 0.5 millimeter to account for any potential shrinking from the 3D printing process and printed out sort of a little placeholder tray just to see how it all fit. Taking the part off the printer and dropping the camera into that little cavity was a pretty awesome feeling, just how perfect it was. I do have a little bit of space if I wiggle the camera still, so I think that maybe I will need to offset, instead of 1/2 millimeter, do 1/4 of a millimeter, but the offsetting is largely going to be depending on what material in the end I end up printing out the finished piece in. I tried a similar approach using the thin scan I ended up grabbing from the top of the Snapmaker, but no matter what I did, I struggled to get that thing to lay flat, and it seemed like when I grabbed a slice of the scan, it just never got the entire geometry. It would capture like a section of it, and the other section would not be passing through the slice. So in this case, I may end up, especially since I still have the stickers on here, trying to do another scan. Hopefully I don't have that weird overlapping issue I had, and then creating a sketch or reference geometry based off of that new scan. Really, I think the key takeaways I have from this experience are twofold. 3D scanners, as well as their software, has clearly gotten a lot better since my last rendezvous with them approximately 5 years ago, both from the ability to capture and capture reliably, the feedback it was able to give me, as well as the cleaning up of the point cloud and the mesh model directly in that software. The second is that working with scans or mesh data is anything but trivial. While I knew I wasn't just going to be able to take a scan and extrude things off of it, I wasn't entirely sure what the process was going to be like for taking a scan and then building something for that initial object, like a mod or an accessory for it. My knowledge of 3D scanning and how to get a good or at least decent scan has definitely evolved over the last couple of months in my time playing around with this in different scenarios. But as far as actually working with the mesh files generated from scanning, I feel like I am just barely scratching the surface. From my own experience here and the many hours of research I've done, 3D scanning still largely feels like a tool to have in the toolbox more than an end-to-end solution. Depending on what your goals are and your purpose for getting a 3D scanner, it can be an absolutely invaluable tool, and some of the examples I saw online on how people were using them professionally was incredible, but you should also be aware of some of the limitations. If you're debating on getting a 3D scanner, I would highly recommend going out and grabbing a scan online, or even just grabbing an STL file and importing it into Fusion or Mesh Mixer or Blender or whatever program it is that you're planning on working with it in, and making sure that you can actually accomplish what your goal is for what you're going to be scanning before you go out and shell over the funds to buy a scanner and realize you can't actually do what you were hoping you could. Now that I have a capable 3D scanner in my bag of tools, I am really excited to see what additional ways I can utilize this technology and incorporate it into my own personal projects. And that has been the Revopoint MetroY and my crash course on 3D scanning. I hope that you enjoyed this video, that you have a much better understanding of what this scanner is, sort of what the workflow is, and what I was able to accomplish and not accomplish. If you do have any additional questions, let me know in the comments down below and I will do my best to answer. As always, if I don't know the answer to your questions, I have no problem reaching out directly to Revopoint to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a new video just about every week to every other week lately, so there's always fresh content coming your way. And if you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys!